Hello everyone, this is Sheikh Faizan Nasir from Perfect Plan B and hope all are doing well. Today we are going to talk about NumPy, and this was one of the most requested things, so I'm just creating a NumPy tutorial. So whenever we talk about NumPy, we also talk about arrays. So what is an array? So an array is a set of contiguous memory allocation. So what basically that means is we store homogeneous data into a list kind of a structure. So what homogeneous basically means is it cannot have any other data type than a single type. So an array can be an integer array, a string array, or a float type array. It cannot contain the same type of elements like a string, a float, and an integer together cannot be inside an array. So there will always be a string or an integer or a float array. And the indexing also starts from 0 and ends at n-1. So it is called lower bound and upper bound, and it is similar to list in this thing. You can also apply indexing, and the length of the array would be 9, which is basically 0 to n-1. So I hope the concept of array is clear. Now moving on, we are going to import some necessary libraries like NumPy, which the tutorial is upon as np, and we are going to import sys and time to actually compare the time and space complexity between standard lists and NumPy arrays. We are also going to use some random data, so I'm importing random, and I'm also going to import matplotlib.pyplot as PLT, which is the scripting layer of matplotlib for data visualization. So running this cell and moving on. So first things first, let's come to the storage comparison. So in case of the storage comparison, I am using the range data structure, and I am storing values from 0 to 999, which basically is the function of range into L, and I am storing 0 to 199 in N also, but the only difference is I am using np.arange. This basically does the similar task as range, but it does not returns a list. In fact, it returns an NumPy array. So in order to get the size or storage of the list or array, we have to do certain things. So what I'm doing here is I'm using the sys module, and I'm using the get size of function, and you have to pass on any integer to actually get the size of an integer. So since we have integers right here, so I'm using any integer, and you have to multiply it with the length of that array or list. So in this case, I am using the length function to get the length, and this will just give me the storage by the list. And in order to get the storage consumed by this complete array, what I have to do is I have to call the n.size, which is basically the length, and I have to multiply it with the item size, which is the size of each element. So this will just give me the storage consumed by the array. So if I run this cell, I should see a huge difference between those two. So you can see that the storage consumed by list is 28,000, while the storage consumed by arrays are only 4,000. So let's come to the time comparison too. So I have initialized the s variable with a random value, which is a huge value again, and I am using the range function to again create two lists, and I'm going to perform addition between the two and compare which one takes lesser time. And I'm doing the same thing for NumPy also, and if I just run this cell, it should initialize my variables. And now in order to calculate the time, I have imported the time module, and to actually store the time when the execution starts, we have to call the time.time function, and we have to store it in a variable. So I'm using the start variable to store this, and I am creating an empty list to store the addition of my list, and I am looping through the range of s, which is basically this range, and I am adding each element with the other. So I am using L1 of I, which is basically L1 of 0 to this value, and similarly for L2, and I'm adding each element and storing it in this result. So in order to print out the execution time, we have to stop the time also. So instead of initializing a stop variable, what I have done directly here is I have called the time.time function and I have deducted the start point. And by default this will just give me the basic seconds of the execution, but I don't want that because the calculation is not that big and the values will be very minimal. So I am multiplying it to 1000 to actually get the milliseconds. So if I run this cell, so you are seeing something like 375 milliseconds. So the similar thing I would do for the numpy array. So the only difference is in order to add two numpy arrays you do not need a loop. You can just write in a1 plus a2 and it will give you the complete addition of those arrays. But in case of list, if I do that, it will just give me the concatenation of the two lists. If I run this cell, and you are going to see a huge difference again. So only 4 milliseconds approximately, not even 4. So there's a huge difference in speed also. So that is why numpy arrays are considered superior over our standard list. Now the question arises, how would you create a numpy array? So in order to do that, you have an array function inbuilt. So you can write in np.array and you can pass on a list and it will just give you the array, as you can see. Now in order to check the data type, if you check the data type of any array, you will get something called numpy nd array, which basically means numpy n dimensional array. Now in order to check the dimension of your array, you can always call the ndim of any array. So I am writing arr1d dot ndim and you're going to see a 1 since this is a one-dimensional array only. Now in order to create a 2D array, you have to follow the same structure, just you have to use a nested list and you have to put a comma in between. And if I just print this out, you are going to see a 2D array. And if you want to see the shape, which is basically the number of rows and columns, you can just call the shape function. And if I write arr2d.shape, it will just give me 2, 4 since we have only 2 rows and we have 4 columns each. Now in the numpy module we also have a function called ones, which basically fills our array with ones given the size as a parameter. So I have given the size as 5, so it should give me 5 ones. Also, I'm going to create a 2D array using the function of ones, and I'm going to give the dimension as 3, 4, and you have to pass it on as a tuple in the parameter section. So it will give me 3 rows and 4 columns of ones in a numpy array. So as you can see, we have got the output. Now we also have a function called empty in numpy, which basically returns an empty array given the dimension, just as we have done before. So I'm giving 3, 4, and what empty array basically means is it uses the cached memory that is available and it does not initializes any element of the array. So if I run this cell, you are going to see anything. So we are getting the same output since this was in our cache memory. And the arange function we have already discussed. It is similar to the range function. The syntax is start, end, and step. So the step is basically how many number of steps you want to skip. So suppose if I write 1, 11, 2, it will go from 1, then 3, then 5, then 7, then 9, and it will stop because 11 is not included in any range. But since I am not giving the steps right now, it should give me 1 to 10. As you can see, I have received an array from 1 to 10, and now I am going to use a function called Linspace. So the Linspace basically does is it divides the two given integers into perfect samples given the step. So this is my step. So I want 1 and 5 to divide it in 4 equal ways. So if I want to do that, I just have to use the Linspace function and the returned array would seem something like this. So we have 1, we have 5, and we have 2.33 and 3.667. So this is the perfect division of 1,5 into 4 digits. So now if I want to reshape any array, so suppose you have any array and you want to actually change the dimension of the array. So this is a function that you will use mostly when you're in machine learning or data analysis. So I have created an array of np.arange, which is basically 1 to 10, and I want to reshape it into 2 columns and 2 rows and 5 columns. So if I just run this cell, you are going to see 2 rows and 5 columns. So we have 1 to 10, but we have it in the shape of 2 rows and 5 columns. So this is reshaping it. So you can use the reshape function to actually convert this into a 1D array, but we have some other functions also. We have ravel to actually convert the n-dimensional array into a 1D array. So if I just run this cell, you're going to see this array converted into a one-dimensional array. So as you can see, we have received a one-dimensional array. The similar thing is done by flatten also, but the only difference between flatten and ravel is that flatten actually gives you a copy while ravel changes the original array. Also, ravel is memory and time efficient, while flatten is consuming more memory and taking more time. So it completely depends on the purpose that you are applying for. And we have a transpose function also. So in case that you have some kind of matrices and you want to transpose it, so you might have studied this in your higher secondary or something, matrices. So whenever we transpose something, we basically change the number of rows into columns and we change the number of columns into rows. So we have this array, right? We have the reshape ARR array. So let's say if I want to do the transpose of this array, what will happen is the number of rows will become 5 and the number of columns will become 2. So if I just run the cell, it will be more clear, and you can see the number of rows are 5 and the number of columns are only 2. So this is what the transpose functions does. Now moving on, we have some mathematical functions to actually perform operations in the NumPy library. So I am creating two arrays of ARR1 and ARR2 and I am printing them out for further usage. So let's say I want to add two arrays. So we have seen one method that just by using the plus symbol we can add two arrays, but we also have a function called np.add and we can pass on the parameters the number of arrays that we want to add and it will just return the addition of those arrays, and we are printing that array. Similarly for subtraction, we have to enter the subtract method and we have to pass the arrays that we want to subtract as a parameter. So if I just print this out, we are going to see, okay, so this is the addition of my arrays, which is basically this array and this array, and this is the subtraction of the same. So in order to multiply arrays too, it is very easy. You can just use the star symbol for multiplication, or you can use the dot function that we have in NumPy. So both does the same task. It is upon your choice to do anything. Now moving on, if you want to find the maximum element in a list, so I am using mul array1 dot max. So this is my mul array1 and I want to find the element that has the maximum worth. So it will just give me the maximum element and I will print it out. And if I want to find the location where it is located, I have to use the argmax function, which will basically give me the index of that element. So if I run this cell, you will going to find that it is 50 and it is located at 3, which basically means this is 0, this is 1, this is 2 and this is 3. Similarly for the minimum element, we have the min function and I'm going to print it out, and again I'm going to call argmin, which is the opposite of argmax, and it will give me the location. So it should give me 19 and 0, and you can see it is giving me 19 and 0. So let's say you want to find the minimum and maximum elements and their locations, and you want to find it within a row or within a column. So I'm writing mul array1 dot min, and if I just pass on this parameter, which is axis equals to 0. So whenever you specify axis equals to 0, it basically means you're trying to deal with rows. And whenever you are specifying the axis as 1, it is basically meaning that you are specifying for columns. Similarly, this was for minimum, and for maximum the same thing that we have done so far. Only thing is we are using the axis equals to 1. So if I just print this out, you're going to see it. So this is my minimum element in the row, and this is my minimum element in the other row. So we have used two arrays here, and this is the minimum element in the column, and this is the minimum element in the column 2. So moving on, we are again storing a list, and we are actually going to find the sum of this list using the np.sum function. So what it will basically do is it will calculate the sum of all the elements and it will return it as an array. If I just print it out, you will see that the sum has been found out by the numpy module. So we can also find out the sum and return it as an array based on the axis equals to 0, which is basically adding this rows. So if I run this out, you can see that it is giving me something like this, which is basically 52, 25, 93, 42 and 67. Similarly for the rows 2, and I will do it as axis equals to 1, and you can see I am getting the rows 2. So this is basically my 120, 75 and 84, and this was for my columns, which is basically I'm getting 5 columns. So let's say you want to find out the average or the mean of the array. So it will just, you can just call the np.mean function, and it will add the elements of the array and divide it with the length of the array, and you will find out the mean of the array. So 18.6 is the mean of this array. Similarly, if you want to find the standard deviation of the array, you can use the np.std function, and you have to pass the parameter as an array. So this is the standard deviation of my array. Similarly, if you want to find the square root, you can use the np.square root function, and you have to pass on the parameter. If you want to find the exponent of the array, you have to use the np.exp function, and if you want to find the logarithm of the array, you have to use the np.log, and you have to pass exarr, which is basically my array, as a parameter. And in order to find the log base 10, you have to use np.log10 function. So this is also giving me the log base 10 of the array. Now it is not practically possible to cover the entire numpy module because it is very vast, but whenever you get any function, you can just head on to the docs. So let's say you want to look into np.log10. So suppose you don't know what is np.log10, so you will just go to a new tab and you will write np.log10, and it will redirect you to this np.numpy.org, and you can just go to the documentation, and it will be written that returns the base 10 logarithm of the input array element wise. So you can always look into the documentations. It is a good practice of a good programmer. Now coming to the array slicing, as I've said that numpy arrays are sliceable too. So if I create an array of this, and if I print it out, and I want to see the first index, which is my 0, and if I print it out, you are going to see that I am receiving 1457, which is on my 0th index. If I print out colon comma 1, which basically means from starting to 1th index, and it is just going to give me 4, 9 and 1. Now if I want to slice it very far, so I'm going to use colon comma 0 and colon comma 2. So I'm going to skip anything that is between, so I'm getting 1 comma 4, which is colon and 3,9 I'm getting, and 5,1 I'm getting. So I'm going from front to end, and I'm going for only the first two elements of these arrays. So this is how we are slicing it up. And now I'm slicing the array from colon to 2, which basically means I'm going to go from 0 to 2, and I'm not skipping anything. Okay, so I'm getting this value. So in order to concatenate, you can just use the plus function in the list. So if I do this, you're getting the concatenation. But in order for NumPy to do that, you have to use the np.concatenate function, and you have to pass on your list or arrays as parameters, and it will return an array of the concatenation. So as you can see, we have received that. And if you want to vertically stack your list, which is basically, converting it into a stack kind of format, you can just use the np.vstack function, and it will return the vertical stack. Similarly, for the horizontal stack, you can do so. This vertical stack is converting it into a vertical format, the horizontal is converting it into a horizontal format. Sorry, just did some empty spaces. So in order to split your array, you can use np.split, and I am using the vertical list, so I want to split it based on this list, and I want two divisions of that list. So if I just print it out, you're going to see two different arrays, which is basically 1 2 3 4, which is the upper section, and 5 6 7 8, this which is the lower section. Now if you want to split it out based on the columns, so you can use this function, which is np.split again, and you can pass on axis equals to 1. So as I said, the axis equals to 1 basically specifies your column. So you're getting 1 2 3 4, you're getting 1 2 5 6 7 8 and 3 4. So this is basically how we are splitting it. And for the random sampling, as I said, we are going to use np2 and random to actually generate some random data, which is basically generating random arrays. So if I write np.random.random and I use 1 as a parameter, so it will return something like this. It will return a floating point number between 0 to 1. Now if I write np.random.random 3, 3, so it will actually give me numbers from 0 to 1 in the dimension of 3, 3. So we are getting just any random floating point number. So in order to get integers, you can use np.random and .randint, and you're giving it as 1, so it should give you one number. So it is giving me a 0. So if I write in np.random.randint and I pass on 1, 4 and 3, 3. So what this basically means is we want random integers from 1 to 4, and we want it in the dimension of 3, 3, which is basically 3 rows and 3 columns. So if I just print this out, you are getting something called 2, 2, 2, 2, 3, 2 and 2, 2, 2. This is the random array that we have generated. Now the seed function. So the seed function basically does is, the seed function actually creates array of, the seed function will basically, what it will do is, if I pass it as a parameter as 10, so what it will basically do is it will not change accordingly. So whenever we actually use random, if we run the cell again and again, the values will change. So whenever we are trying to share our code and using random values, we use the seed function so that our output is not changed. So if I use the seed function and pass on any parameter, so our random, whenever we use random, it will not change for every user. So here we are again passing on the same thing, and we should get something like this. So we are going to generate positive and negative random numbers, so we can use np.random.randn and we can pass on the tuple as the dimension, and we should get positive and negative numbers. So we have negative numbers and positive numbers, and we have it in the format of 3, 4. Now we also have a choice function in np.random, which basically returns a choice from a given array or list. So we have this list called x, and we have some random values inside it. So if I just write in np.random.choice and I pass on the list of or the array, this might contain strings, so it will just return a random value between these only. So we are getting a 5. The next time I run it, I'm getting a 6. So this is what I was talking about in the seed function. So if you use seed, it will not change again and again. So print random.random.permutation of 2. So it is generating a random permutation, and the size is given as 2, so I'm getting 1 and 0. And to shuffle off any array, you can use np.random.shuffle, and I want to shuffle it the x, so it will be shuffled. If I just run the cell, you're going to see none. And for string operations in NumPy, we can use the np.char module, and we can use the add function. So I have initialized sk and Fazan into the first name and last name, and I'm actually trying to combine this. So I'm using the add function, and it should give me sk Fazan together. Let's say I want to convert it into uppercase, so let me just convert this as sk only, and my k is in lowercase. And if I just run the cell again, and if I run this cell now, it should give me sk in uppercase. So we are getting the uppercase. So in the string 1, I have stored uppercase, and I want to convert this to lowercase. So I can use in np.char.lower, and I can pass on the string 1, which will basically give me the uppercase. Now np.char.center, and first name 60 fill char equals to star. What basically this means is it will print out the first name, which is sk in this case, and it will fill characters of star 60 on both the sides. So it will be divided into two sides, and you can see that it is filled with stars, and the first name is printed in between. Now let's say we want to join two strings, and we want to insert some characters in between. So we have our first name and last name, and let's say I want to add a colon between these, and I want to add slashes between these alphabets. So I can use np.char.join, and I am passing on this colon, and I am passing on the slash, and I have to also pass on my first name and last name variable in a list similar to this one, and it will just insert this in wherever the string is broken. So you can see we have received something like this, which is s colon k, and we have Fazan, and we have slashes in between. So this is what the join function is doing in this case. Now let's say you have a string, but you want to replace something with the other. So here I have taken a string, and it is written as I am a web developer. So let's say you want to replace web with ML. What you can do is you can write np.char.replace, and you have to pass on the string that you want to actually use to replace, and you have to pass on web because you want to change the web to ML, and you have to give the other string as a parameter too. So if I print this out, you're going to see I am an ML developer. So if you want to check if two strings are equal or not, you can use the np.char.equal function, and you have to pass on two parameters, which is the two strings. So I'm using string 1 and string 2. So let's actually run this cell, and you're getting false because string 2 is I am a web developer, and string 1 is uppercase. So it is a false. And if you want to count the number of any character that is present inside a string, you can actually use the np.char.count function, and you have to pass on your string as a parameter, and you also have to pass on the character that you're actually looking for. So I'm looking for E inside string 2, so it should give me 1, 2, 3 and 4. As you can see, I have received a 4. Now let's say I have this string hello slash n machine slash n learning slash n world, and I want to split these lines and actually print it out. So I'm using np.char.split lines, and I am using str3. So slash n will be considered as a new line, and you can see we are getting hello machine learning world in a list or a numpy array, you can say. So these are a few functions that we are covering in this tutorial, and we also have trigonometric functions in numpy. We are using the np.arange, and we are going from 0 to 4 into np.pi, which is basically pi, and pi is basically 22 by 7. We are multiplying it with 4, and we want to go from steps 0.1. So it will go from 0, 0.1, 0.2, something like that. And we are using y is equal to np of sine of x. So whatever is in x, we will convert it into a sinusoidal function using the np.sine function, and we are actually plotting this sine function based on our x, and we are using the plt.show function to actually print the output. So this is how it looks. You will receive a separate tutorial on matplotlib, but for now just assume that this is the sine function. And similarly for the cos function, we are using the same thing. The only difference is we are using the np.cos function in this case. So this is a cos wave, this is a sine wave, and let's generate a tan wave now. We are using the tan x function, and this is how a tan wave looks. Now this is a code that you all are maybe familiar with. You have seen it in the sklearn code. So I am using random.c42 and np.random.c42. So what basically this means is it will basically, whenever the code is run again and again, it won't change the values as I've said earlier. So I am saying ages equals to numpy.empty of 100. So I'm creating an empty array, and for I in range of 100, I am appending this array, and I am using the II to actually access the indexes, and I'm storing np.random.randint 20,65. So I'm taking from 20 to 65. So anything that will be stored inside here will be between 20 and 65 as an integer, and the length of this array should be 100. So if I just print out the ages, you're going to see every value that is existing here is between 20 and 65. And if I just print out the length of these edges, you're going to find that it is only 100. So this was all about the NumPy tutorial. I'll share the code with you, and I hope you understood the code and the practicality of this session. I hope all your doubts are resolved, and if you have any more doubts, you can just post it on your Piazza groups, and I'll see you in another video. Till then, take care.